Assalamualaikum warahmatullahi wabarakatuh. Today we have decided to choose mixture for the application of first ordinary differential equation for our group project. Before we start, let me introduce you to my group mates, which are me, Sofia Iliana binti Abdullah, Siti Shafika binti Osman, Nurul Maisara binti Bukhari Rajab, and Amira Izati binti Rosman. For the introduction, mixture problems are an application of linear differential equations. There were problems that required us to create a linear differential equation based on the concentration of a substance in a tank. Usually, we'll have a substance like salt that's being added to a tank of water at a specific rate. At the same time, the salt-water mixture is being emptied from the tank at a specific rate. We usually that the contents of the tank are always perfectly mixed, and we ask to model the concentration in the tank at a certain time. The formula we use to model concentration is dA per dt equals to C1 times R1 minus C2 times R2, where C1 is the concentration of the substance being added, R1 is the rate at which the substance is added, C2 is the concentration of the substance being removed, and lastly, R2 is the rate at which the substance is removed. Next, I will pass to the next presenter to talk about problem statement.
Next, problem statement. The question have stated that a tank with capacity of 175 liter contains 100 liter of brine with 5 kg of dissolved salt. A brine solution that has a concentration of 3 kg per liter is pumped into a tank at a rate of 10 liter per minute. The solution is kept thoroughly mixed and drains from the tank at the same rate. Then, the question asks, find the amount of salt in the tank after 6 minutes. Secondly, if water flow in at a rate of 5 liter per minute, determine when the tank will be empty if the outflow remain unchanged.
Moving on to the next part, which is the solution of the question. So to solve this question, we have to identify the C1, R1, R2, and C2. So from the question, it is given that the concentration of 3 kg per liter, C1 is equal to 3. And next, it is given that a rate of 10 liter per minute, which is the R1. So the R1 is 10 liter per minute. And then for R2 it says it thoroughly mixes and drains from the tank at the same rate. So that means the R2 is equal to R1, which is 10 liter per minute. And what is missing is C2. So to find C2, using this formula, AT over with VT, so what we have to find is the VT. To find VT, we have to use this formula and substitute the V0, which is the initial volume of solution in the tank, plus with R1T minus with R2T. So substitute all the elements into the formula, and then we get the VT. And then substitute the VT into the C2 formula to get C2. Now that we already have C2, so we can substitute into the model and substitute into the formula. Then solve the following equation and write it in the linear standard form. This is the linear standard form. Next, determine the PT. This is PT, so this is our PT, which is 1 over 10. Now that we already have the PT, we have to find the integrating factor using this formula. and then integrate the bt, and we will get E1/10t. Now that we already get the integrating factor, we have to multiply it to both sides. The next step is we have to integrate both sides of the equation. And simplify it. Next, apply the initial condition to find C. This from the equation A0 is equal to 5. And substitute the T is equal to 0. We solve it. E0 is equal to 1, so this is the only C. And we will get the C is equal to -295. The question asks to find the amount of salt in the tank after 6 minutes, which means the T is equal to 6. So what we have to do is just substitute the T with 6. And then we will get the answer, which is 138.1 kilogram. Therefore, the amount of salt in the tank after 6 minutes is 138.1 kilogram.
Moving on to the second part of the question. The question asks us to determine the time of the tank will become empty if the water flows in at the rate of 5 liters per minute and the outflow rate remains unchanged. With this, the R1 will be 5 and the R2 will be 10. We will now substitute this into the BT formula, which is VO plus R1T minus R2T. After substituting, we will now get 100 minus 5T, and since the VT is 0, we are now able to find the value of T, which is 20. With this, we can conclude that the tank will be empty in 20 minutes. To sum it all up, mixture problems are an application of separable differential equations. They are word problems that require us to create a separable differential equation based on the concentration of a substance in a tank. We will first need to substitute all of the information given into the mixing problem formula. After that, we will need to separate the variables and then integrate both sides of the equation and then try to find a general solution, which for this question is 300 plus CE to the power of -1/10t. After applying the initial condition, we can then obtain the value of C, thus giving us the expression for the amount of salt in tank at time t. And finally, after substituting T equals 6 in the equation, we can now find the amount of salt in the tank after 6 minutes, which is 138.1 kilograms. With this, we can conclude that it is important for us to learn about mixture problems as it can be used in a variety of real-world problems.